a member of X, okay, because it's listed here. Is 4 also a member of Y? Yes, it is. It's listed here. So 4 is in both sets, so 4 must be in the intersection, okay? Let's take 6. Well, what about 6? X is equal to 6 is certainly an X, okay? 6 is there, okay? Is 6 also in Y? Yes, 6 is in Y. So 6 is in X and it's in Y. So what we know is that 6 must be in the intersection. And let's take 8. Here we go. So 8 is certainly an X. It's listed there. Is 8 also listed in Y? Yes, it is listed in Y. So 8 is also in the intersection. Okay. Now, actually, logically, we don't need to go on. We don't need to search through Y to find values that are in Y that are in X. Because if values are in Y that are in X, we would have found them when we were going through the X values. If that makes sense. Okay. But let's actually just continue and let's just do it. Okay. So now let's take the set Y. Okay. 4 is in Y. Is it also in X? Yes, it is. So 4 needs to be in the intersection. Well, we've already listed it. What about 6? 6 is in Y, so 6 is in Y. Is 6 in X? Yes, it is. It's listed here, so 6 should be in the intersection, which it is. And we found that on the first pass. What about 8? 8 is certainly in Y. Okay, so that condition is met. Is it also in X? Yes, it is. So 8 needs to be in the intersection. Okay. And what about the final value in Y? We have 10. 10 is in Y, so we meet that condition. But we need to also meet the condition that it needs to be a member of X. Is 10 a member of X? No, it's not. Okay. So 10 can't be in the intersection. So actually, the intersection of X and Y is equal to 4, 6, and 8. Okay. Let's do another example, okay? So let's take, as an example, okay? So let's take an example, okay? Let's say X is the set that contains the values 2, 3, and 4. And let's say that Y is the set that contains the values, let's say, 6 and 7. And what we'd like to construct, okay, is we'd like to construct X intersection with Y. Okay. And don't forget, by the definition, X intersection with Y is a set. It contains members or elements, and the condition associated with the members is that they must be in X, okay, and the members must be in Y. Okay. So what do these members look like? Well, let's have a look. So X intersection with Y, it's definitely a set. Okay. The things that must be in here must be in X. So the candidates are 2, 3, and 4. Okay, but are any of these candidates in Y? No, they're not. Okay, 2 is in X, but 2 is not in Y, so it's not in the intersection. 3 is in X, but it's not in Y, so it's not in the intersection. 4 is in X, but it's not in Y, so it's not in the intersection. Okay, so far we haven't found any elements that are in the intersection. What about Y? Well, 6 is, and once again, we don't need to do this because we've exhausted all the values in X already, but let's just do it just for convenience. So 6 is in Y, so it meets that condition. Is 6 in X? No, it's not, so it's not in the intersection. What about Y? What's when 7? Well, 7 is definitely in Y, it's listed there. So 7 is in Y. Is it in the intersection? No, it's not. It's not listed. So actually, when we go through the set X and the set Y, what we see is there's nothing shared. There's nothing in the intersection. So actually, X intersection with Y, it is a set, okay? But this set that we get is a set that contains no values, which is the empty set, okay? So we have the empty set here, or sometimes that's symbolized by a symbol that looks like this, okay? So in this situation here, the intersection of two sets ended up to be the empty set. Okay, guys, once again, this was Jonathan Lambert with the Mathematics Development and Support Service at the National College of Ireland. And this short example introducing us to the two operators, the union operator and the intersection operator, okay, as part of our set theory. Okay, I hope that this example was in some way intuitive, and more importantly, I hope that was in some way helpful. But maybe let's just reflect on this again. If you think about a set to be like a shopping bag with that magic property, okay, that there's no duplicates in it, well then the union of it is when you have two shopping bags, X and Y, okay, what you do is you create a new shopping bag and you throw the contents of X into this new shopping bag and you throw the contents of Y into the new shopping bag. This creates the union, and once again the magic property of sets kicks in where there's no duplicates. So the union of two sets is like us creating a larger shopping bag that contains the contents of both sets. Okay. Whereas with the intersection operator, okay, the intersection operator is where we have two shopping bags with objects in them or members in them. We have two shopping bags, okay. The intersection is, well, the only thing that goes into the new shopping bag are things that are in both of the sets simultaneously, okay. So you can see that Ford is in X and Ford is in Y, so it's in this new set. Okay guys, once again, this was Jonathan Lambert with the Mathematics Development and Support Service at the National College of Ireland, and I hope that this video was in some way intuitive, and more importantly I hope it was helpful, and thanks for watching.